Hello and welcome to Developer Week 2022. It is my pleasure to introduce our first presenter. This is, excuse me, Ben Boral. He is a solutions engineer for Bitrise. He'll now be joining on screen. Thanks.
Hey, everybody. My name is Ben Boral. Yeah, I'm a solutions engineer at Bitrise, and today we're going to be talking about 7 steps to ultra-fast continuous integration. A lot of these tips are going to be useful for non-mobile projects, and a lot of them are going to be very specific to mobile. So first, I just want to find out a little bit about the audience. Can you post a hand wave or a smiley face emoji if you are a mobile developer? Just post that into the chat. All right, cool. Lots of smileys, and I guess we'll do smileys for mobile developers. And how about like eng managers or people focused on operations, thinking about DevOps within their organization? We'll do a hand wave for that. All right, cool. We got at least one of those. Well, a couple of those. Well, welcome to the talk. So like I said, it's going to be ultra fast mobile continuous integration, and we have a lot here, so it's going to be a pretty fast talk. But myself and a bunch of other people from Bitrise are going to be available in our booth. So if you see anything in this talk that you're curious about and need clarification on, just come talk to us in the booth. So a little bit about Bitrise. We are a CI/CD product, which is tailored to the mobile use case. And today we support over 100,000 developers and over 6,000 mobile organizations. And a little bit thinking about CI. Why do we want fast CI? Well, Martin Fowler has this pretty great quote: "Nothing sucks the blood out of a CI activity more than a build takes a long time. And as developers, we know this intuitively just from having to wait around for builds. Like whenever you, let's say, push up a change and then you have to wait a long time to see that it failed. And then you got to like do a simple fix and wait a long time for it to pass. And as managers, we know, or just people thinking about the business outcome, we know that faster builds means developer time saved, and we know that adds up fast. And then we also know that faster builds means more integrations. That means more iterations and more innovation. So there's really a connection between fast CI and delivering business value. So my goal today is that every single person in this session learns at least one thing that you will take back to your group and apply to some CI within your team to speed up your builds. And so let's just get an outline of the bag of tricks that I'm going to share. Some of these are conceptual, some of them are very concrete, some of them are kind of basic, and others are advanced. So no matter where you're coming from as you watch this session, like there should be something in here for you. The first is how we can adjust parameters on Git to speed up our clones. We'll look at Xcode Build for iOS and macOS or any Apple builds. Gradle settings for our Android builds. We'll look at some cloud tools. If we're running Android emulators for, let's say, UI tests, we'll look at some configuration we can make to speed that up. dependency caching in our CI builds, and then how we can use vertical scaling or really just bigger machines to speed up our builds. So starting with Git Clone, Git is a version control system, and one of the great things about it is that whenever you, oh, I see somebody has no sound, but I think based on the smileys and the hand claps, my sound should be working. So Git, is great because as a distributed version control, it allows us to clone the entire history of changes of our repository onto our local machine. But if we're thinking about our CI builds, we don't need all of that. We really just need the portion of the code that we're trying to build and test. And if you're cloning more than you need at the beginning of your build, especially on a really large repo, then you're just doing extra work and wasting time. So there are a few things that we can do to speed up our clones at the beginning of our builds. The first is we can set a shallow clone depth. And this is useful for builds that are triggered based on pushing a commit or tagging a commit. And that is a setting on the git clone command that we can set. We can just set clone depth to 1, and it will only fetch the latest version of the code. We can also do a sparse checkout, and this is really useful for mono repos. So let's say that you have a mono repo and there's one team working in one directory and another team working in a different directory. Well, for your builds, you really only need the directory that you work in, and you can use sparse checkout to only fetch the directories you care about. And then finally, treeless clones. So basically what this does is it will fetch the entire history of the entire commit history of the repository, but it won't fetch the contents of files and directories. It will only grab the files and directories that it needs on demand. And so this is useful for pull request builds, because whenever you want to merge your source branch into your target branch, you have to look back into history to find their common ancestor. And so if you just fetch sort of the list of history without the actual contents of the files, you can do that quickly. Look back into history, and then on demand, just grab the files and directories that you know you need to make that merge. So you can really think of it as lazy loading for your merge. And this is so particularly applicable to pull requests where we need to do that work. But on push triggered or tag triggered builds where it's just one commit hash, you don't need to do this. So let's look at some examples. I played around with 2 repositories. The first is the Linux repo, and the other is React Native. We can see Linux is 3.5 gigs, 1 million commits. React Native is 700 megs, 23,000 commits. So just totally clean full clone of these repos, 10 minutes and 17 seconds. And then if I limit that to a shallow clone, we basically speed that up by an order of magnitude. So you can see how on a really big repository with a lot of history, this makes a big difference. If I then combine that with a sparse checkout, I can decrease that even more. And on Linux, in my example, I think I just did a sparse checkout for the kernel directory. And then finally, if I do a treeless clone, similar order of magnitude, I'm bringing that down pretty significantly. So come to our booth and we can talk more about the exact parameters that you will use for these, but conceptually, this is what you can do to bring down your clone time. All right, so next up is Xcode Build. So this is for our Apple developers. And the first thing is a setting for compilation. In Xcode 13.2, Apple released a feature which is still experimental, so you have to opt into this. But if you opt in using the command on this slide, then you will enable the Swift compiler to use all the available cores on your build machine. So I did a quick example with Swift lint, which is a Swift program. And my baseline build without this setting was 63 seconds. And then whenever I opted in to this setting, I was able to bring that down by 10 seconds. So this is a pretty small repository. You can imagine that for a really big project, this is going to make a more significant improvement. Another thing for our iOS developers in the room today, whenever you're running UI tests, you can use the parallel testing enabled and parallel testing worker count options on Xcode Build. And so what this will do is it will spin up additional iOS simulator clones. And so you can run your tests in parallel. So let's say you had 30 tests and previously you only ran them on one simulator. Then you were running, 30 tests serially. But let's say you're able to spin up 2 additional simulator clones. Now you've decreased your test execution time to a third because you're able to run those UI tests in parallel. Moving on to Gradle. So this is for our Android developers in the room. The first thing I want to point out is the scan option. This is something that Gradle makes available to you. And essentially what it'll do is it will profile your Gradle tasks and then provide a report on the performance of your Gradle task. And so you get really, really actionable information here. Information like the subtasks, are they running in parallel or are they running serially? We want them to run in parallel, right? So that everything happens at once and then the overall Gradle task execution time is very quick. We can also see memory consumption, and then the profiler will actually offer suggestions for speeding up your Gradle task. So this is an example of some of the suggestions that it offered me on a recent build. And this is a visualization of the task execution that I ran. And so you can see where those 3 turquoise bars are. Those were 3 subtasks that were able to run in parallel. And then to the right of that, there were 2 long-running tasks that had to run serially. And so now I'm able to identify, okay, which tasks take a long time and which have to run serially, and I can work to optimize how that runs together. All right, a few more Gradle tricks. So the next is to have a look at your Gradle.properties file. So the first thing is that there is a recent garbage controller that you can use with Gradle. And essentially what it'll do is run some of the, I think I said garbage collector. It'll run some of the garbage collection tasks in parallel with Gradle tasks. And so it won't have to pause the task execution to do garbage collection. And so this will speed up your Gradle builds. Another is to set the Gradle parallel flag to true. So for Android developers, if you have a multi-module project, then this will be able to build those modules in parallel. And then another is to increase the available resources. So you can use JVM args to increase the heap space available to Gradle. This is an example where I've done it specifically for the lint debug task, and that's because linting is a very resource hungry task. And you'll notice that it's not just a lint task, it's a lint debug task. So that's my next suggestion, which is choose the right task. Because when you run a Gradle lint on your Android project, what you're doing is actually running the same lint task for every single variant within your Android project. So instead, just choose a variant and run linting for that one. Otherwise, you're just repeating the same work over again. And linting is a resource-hungry task that takes a lot of time. So this is one that is ripe for improvement. My next tip for speeding your mobile CI is to use the infinite throughput of the cloud. And what I'm talking about here in particular are device cloud vendors. So there are a bunch of them. I've listed a few on this page. But the idea is similar to what I was talking about on the parallel test execution slide within Xcode Build. And basically what that means is that if you're spinning up a simulator or an emulator within your build VM, that is using resources on that build VM. Why not use dedicated resources, either devices or virtual devices, simulators and emulators, that are in the cloud? And then if you're doing that, you can spread your UI tests across as many of those devices as you have available to you. And there is a really cool library called Flank, which is tied to Firebase Test Lab, and actually allows you to shard your UI test suite and run up to 50 test executions on real devices or 250 test executions on emulators at the same time. So you can massively parallelize using Flank and significantly speed up your UI test execution time. Let's say that for some reason you're unable to take advantage of a device cloud. How can we speed up our UI tests if we're running them on an emulator inside our build runner? Okay, the first thing that we can do is start the emulator in the background. So emulators take a couple of minutes to boot up. And so my tip here is use the AVD Manager command, which is built into Android Studio. Use AVD Manager to boot up an emulator. And then do your Git Clone and your Gradle build, all the other work while that emulator is still booting up in the background. And then by the time your tests are ready to run, that emulator is ready to go and you're not wasting time waiting on it. Next tip is to use emulators with low pixel density. So I did a test running a set of sample tests on a Nexus 5 with a relatively high pixel density. Took 71 seconds. And then I ran the same tests on a Nexus 1. Both of these are emulators with lower pixel density. Took 55 seconds. And you can, it sort of makes sense why, right? Like the emulator is not working as hard to draw the page. So you're able to improve performance there. Next is a new emulator which is designed for UI testing that the Android team recently released. It's called Automated Test Devices. Essentially, they're removing a lot of bloatware and background services that are unnecessary for UI tests. And at Bitrise, we've started testing these internally. And we see that automated tests are running 20 to 30% faster in aggregate. Right now, this is in Canary. So it hasn't reached a stable release yet from the Android team. I think that'll be happening very soon, and you'll see really nice speed up if you use that device image for your emulator UI tests. All right, this is our second to last tip. It's a pretty basic one, but a good reminder. Experiment with caching your dependencies. So I put together a sample app. It's a Carthage app for iOS, and it has one dependency, which is the Alamo Fire networking library. And when I ran a build, the Carthage step, which downloads and builds the Alamo Fire dependency, took 1.7 minutes. And then when I added in caching, so I cached that dependency, and I reran a build, this is on Bitrise, I added a cache pull step that took 3.5 seconds. And then my Carthage step only took 11 seconds. So we're basically able to eliminate like 1.5 minutes of time by using caching. The more dependencies your project has, obviously, the greater improvement you're going to see here. Okay, and then my last tip is really the easiest one, vertical scaling. So if you run your builds on a bigger machine, you're going to have a faster build. And so I just want to take a minute to tell you about Bitrise offerings. Our build VMs go up to what we call our Elite XL. That's 12 virtual CPUs and 54 gigs of RAM on Mac OS. And on Linux, 8 vCPU and 32 gigs of RAM. And then this is the really exciting part. We are in private beta right now with Mac M1 build runners, so Apple Silicon. And our internal testing shows that compared to our largest Mac OS Elite XL machines, we're seeing a 31% speed improvement on top of that. So really nice improvement. As I said, it's in private beta, but we're opening that up imminently. So I recommend that you go to bitrise.io/M1 pre-register and get enrolled so that you can join the beta as we continue to open that up. And remember, nothing sucks the blood of a CI activity more than a build that takes a long time. So definitely always stay focused on keeping fast CI builds. And again, if you had any questions about this, I went pretty fast. There was a lot there. I'm going to be back in the booth right after this talk. And I'll be around most of the morning, and we'll have an official Q&A at noon today. And then come join us again tomorrow at 8 a.m. My colleague Moataz El-Debsi, who's one of our developer advocates, is going to be giving a talk in the booth, so it's in the booth, on mobile app testing at scale. And then couple hours later at 10 a.m., we'll have another engineer Q&A. So come find us in the Bitrise booth for those. And thank you everybody for attending.
Thank you, Ben, for a great talk. Developer 2022. Attendees, please navigate to the next available talks to the session tabs to your left. Thanks, Ben.